Welcome back to Geometry. We're at section 10.4, Perimeters and Areas of Similar Figures. Our first note, first line says that given similar figures with a similarity ratio of a to b. Now remember, a dot dot b is the same as a fraction, so I can put a over b. And that's generally how I like to show ratios. It just makes more sense to me seeing it in fraction form. Then the ratio of the perimeters are also going to be a to b, or a over b. However, what changes is that the ratio of the areas is going to be a squared over b squared, or we can show that as a squared to b squared. Alright, we're asked down below to find the ratio of their sides. And so first thing that we want to recognize is that the ratio of the sides and the ratio of the perimeters, these are always going to be the same. They're always equal. Okay, so the side ratio and perimeter ratio are always equal. The one that will be different is the area ratio, and we'll find out why we use that in the word problems down below. Okay, and so again, this is going to be our a squared over b squared for the area, and the side and perimeter is going to be a to b, or a over b. Alright, in this first problem, you can start with a base or a height. I'm going to start with the base. We have one base 5 and one base of 10. Now, you are told in the problem that these shapes are similar, okay? And so since these shapes are similar, it means that this angle is congruent equal to this angle. It means that these two angles are the same as well, and we have our 90-degree angle, okay? And that means that the shapes are similar and the sides are going to always be proportional. So we have a height of 5 and height of 10. I'm going to write 5 over 10. I'm going to reduce 5/10 and I get 1/2. So 1/2 is going to be my side ratio. It's also going to be my perimeter ratio. Okay, and then we're also asked to find the area of the ratio, or the ratio area. So we take at 1/2, we square 1 and 2, and we get 1/4, and that's going to be our area ratio, 1/4. Alright, next problem. Let's start, I guess we'll use our smaller numbers. We'll do the base of 9 and 6. So we reduce 9 over 6, we get 3/2. And so again, 3/2 is our side ratio. I'll put SR, and it's also our perimeter ratio, or PR. Alright, we have 3/2. And then we're also asked to find the area, or the ratio of the area. We take 3/2, we square it, and we get 9/4. And so that would be our area ratio. Alright, and then next shape, let's take a look at 4 and 10. So 4 over 10 would reduce to 2/5. Again, 2/5 would be our side ratio and our perimeter ratio. And then to get the area ratio, we square it. And if we square 2/5, we get 4/25 is our area ratio. Alright, we'll see down below why we use those ratios. If the perimeter of the smaller figure is 27 units, so perimeter is equal to 27. Use your ratio of the perimeters to set up a proportion to solve the ratio of the larger figure. So our goal is to find the perimeter of this shape. Now remember, we have to add up all of our sides, and we don't know these sides, okay? But we do know the height, and we do know the base. So what I can do is I can set up side ratio. So we look at our height of 3 and 4. I'm going to use 3 over 4. Now remember, 3 over 4 stands for a side ratio. It also stands for a perimeter ratio. So that's why I'm allowed to use 3/4 is going to equal. And since I'm going small over big, this is my small perimeter, and my big perimeter is going to go underneath. All right, and then to solve, we're going to cross multiply. 3p equals, is that 118? Or no, that's 108. And then p is going to be equal to 36. That's our perimeter of the large shape. All right, next, we're told the area of the larger figure is 40, and we do not know the area of the smaller figure. If you start with 9 over 4.5, this is a challenging fraction to reduce, so I'm not going to use 9 over 4.5. I'm going to use 20 over 10, because 20 over 10 is much easier to reduce. We get 2 over 1. Now, let's keep in mind that 2 over 1 is a side ratio. It's also a perimeter ratio, but we're not being asked to find perimeter like we were in this last problem. We're being asked to find area. So we actually have to next convert it to an area ratio. So I square 2 and I square 1, and that gives me 4 over 1, and that's my area ratio. So that's what I'm going to use when I set up this proportion. I'm going to take my 4 over 1, it's going to equal, and I'm going big over small, and the big area is 40, small area is unknown, 4a equals 40, a is equal to 10, so the area would be 10 units squared. Alright, we also have the problems excuse me, down at the bottom. And alright, let's start with our formulas. The area of a circle is always going to be pi r squared. To find circumference, which stands for perimeter, it can either equal 2 pi r, or you can do pi times diameter. Problem 1, c is equal to 2 pi times 8. That's going to be 16 pi. Area is going to be pi times 8 squared, so we get 64 pi centimeters squared, and that's centimeters. This circumference on the right, c is equal to 2 pi times 14, which equals 28 pi millimeters. The area is going to be pi times 14 squared, so we get 196 pi millimeters squared. Alright, then on the word problem, we're going to work backwards to find the circumference. So we're told that a circle has area of 49 pi feet squared, and if area is equal to pi r squared, I'm going to substitute in 49 pi into the area. That equals pi r squared. I'm next going to divide by pi, and if 49 is equal to r squared, that means 7 is equal to r. And then the last thing that I have to do is they're asking for circumference, so c is equal to 2 pi times 7, c is equal to 14 pi. Thanks for joining us. See you next time.